All right. Well, welcome everyone. I'm Rob Amberzetti, training director at KGG Consulting, and I want to welcome you to the first ever REPtalk live stream with a special guest lecturer and live audience. Before I introduce today's guest, I'm going to mute everyone to improve the quality for everybody else. And at the end of the session or end of the presentation, Jeff will be able to take some questions from you all. And at that point, you can unmute yourself or use the chat box. So with that, I'm honored to introduce our distinguished guest, Mr. Jeffrey May. Jeff May is principal scientist at May Indoor Air Investigations, LLC, located in Tingsboro, Massachusetts. His company investigates moisture, odor, and mold problems throughout the U.S. Jeff is the author and co-author, along with Connie L. May, of My House is Killing Me. Second edition was just recently released last year in 2020. My Office is Killing Me, the original, was released in 2006. He also has published The Mold Survival Guide, 2004, and Jeff May's Healthy Home Tips 2008, all published by the Johns Hopkins University Press. With that, Mr. May, thanks for joining us and take it away.
Well, thank you, Rob. I'll say if you don't make any money on books.
Well, we try to help.
Yeah, all the work that goes into it, but it gets your name out there. It's nice.
Absolutely. Okay. We're thrilled to have you here. Thanks for agreeing to do this.
What we're going to talk about is kind of what's really out there in the field. I guess when you set out a piece of equipment, maybe you don't always get to look at it when it's been around for a while. So when I first gave this talk, I gave it to the National Filter Association, and I had asked all these filter salespeople, what was the main purpose of the filter, to improve the air quality, or to clean the air by removing particles that can soil the coil. And the way people sell these things is to improve the air quality, so all the hands went up for A. So I just want to talk about what's in air for a little bit. And I do a lot of microscopy. I've done about 35,000 samples from indoors, outdoors, in different kinds of environments. So in the outdoor air, these are pollen grains, that's in the outdoor air in the spring and the summer, and then there are trichomes. And then there's various soil particles, mold spores, and you can have car tire particles in the air. You can have rust, all kinds of things. So that's the outdoor air. The indoor air is very, very different. And basically now I use a pink stain, and it's called acid fuchsin. So it stains anything with protein pink. So, most of the indoor air is skin scales, so the big round pink things. And then you'll find some pet dander in the air. And then, if people are using cornstarch body powder, you'll see starch granules, or if people eat in bed, I'll find starch in their bed. So those are the kinds of things that you'll find. You'll see mold spores too, of course, but the air is very different indoors from outdoors. The filter is supposed to really remove all of this dust. And if you don't keep the dust out of the system, then you can run into all kinds of problems. So most of the indoor dust is biodegradable. As I said, it's skin scales, pet dander. You'll get some pollen, plant materials, cornstarch, fibers from clothing. And all of these things become food for microorganisms if the conditions are right for them. So you need, high humidity or leaks, any kind of dampness, and you'll get the growth of these microorganisms. They can grow on wood, they can grow on all kinds of things, but we're focusing mostly on what they grow on from the dust. But I do want to talk a little bit, just to clarify, different kinds of fungi, because there's a lot of misunderstanding out there. So there are two basic kinds of fungi. There are macrofungi, and the macro means big, and you can see it. And those are the mushrooms. And so the macrofungi are wood decay organisms. And this is a mushroom growing through the foundation wall. It was probably growing on a piece of wood that got buried outside the foundation. And these are other macrofungi, and Serpula lacrymans is one of the real serious rot problems in buildings. So those are macro fungi. They destroy wood, and I forget what the number is, but maybe it's 10% or more of wood in service has to be replaced because of wood decay. So it's a serious problem. Now, mold, on the other hand, are called microfungi, micro meaning small. So the fruiting bodies of macrofungi are big, they're mushrooms, you can see them. The fruiting bodies of the microfungi, they're called conidiophores. They're microscopic, you can't see them. And there's a huge difference between the macrofungi and the microfungi. Microfungi are not wood destroying organisms. I'll repeat that. Microfungi are not wood destroying organisms. So, for example, you might see an entire house full of mold. It's not going to really be destroying anything. It can be cleaned. It may mar surfaces, but there are very few microfungi that actually destroy wood. They do. The spores, however, obviously are a problem. They cause all kinds of allergy problems, respiratory problems, different lung issues. So the common genera of fungi include Stachybotrys, the so-called toxic black mold, Aspergillus, Penicillium, Cladosporium, Chitomium. So all of these different genera of mold have actually black spores, some of the species anyway. So there are millions, or I shouldn't say millions, but thousands of black molds, and people get all sort of freaked out when they see black mold and they think it's black toxic mold. In fact, it's just usually it's Cladosporium, that's the most common mold. And then Chitomium grows on wet drywall along with Stachybotrys. But they primarily cause, what's important here is they primarily cause surface decay, or I should say, degradation of surfaces. So when you look inside, and this is the inside of a heating cooling unit, there's a cooling coil there, and there's a lot of white stuff. And that white stuff is probably zinc oxide. It's oxidation from the zinc, from the moisture that's been in the condensed or splashed off of the coil. But there's typically going to be a lot of mold growth there. You don't necessarily see it. So what you're seeing there in that picture is just oxide of zinc from the galvanized metal. But we have a lot of other slides that have a lot of mold on them. So this, for example, was from a home where somebody was having allergy and asthma symptoms. This was the insulation in the fan coil, and there's at least 3 or 4 different kinds of spores here. So the fibrous lining material can become severely contaminated with mold growth, and the spores get into the air, people breathe them in, and they get sick from that. So I did actually a study in which I compared 600 sick houses to 300 control houses that I had done for real estate for pre-purchase agreements. And I just looked at a couple of different sort of variables or factors. So just really the most important thing is central air conditioning down here. So if you notice in the control houses, 19% of the houses in the Boston area had central air conditioning, and 37% of the sick houses had central air conditioning. So if you're living in a house with central air conditioning, you're twice as likely to have respiratory problems. And that was really the biggest factor. So that's really on the forced hot air was also, there was significant differences there, but primarily the central air was the issue. And so, you might ask why. So a lot of these slides now show you why. Like here's an air conditioning coil that's so impacted with mold that you can't even see the fins. The fins are way here at the bottom and above the condensate pan. And this is a micrograph of the dust that came off of that coil. It was all hyphae. You could actually make a sweater out of that. It was so rigid, you could pull that entire piece off of the coil and use it for cloth. That was so woven together by the hyphae. Just don't give it to a friend. So if the filter doesn't cover the entire coil, you get bypass and you get deposition of dust. Here again, this is all mold growing on a coil, mold growing at the bottom of the coil, on the coil, again, mold on the coil. So the bottom line for all of this is you cannot have dust on a coil, because if you have moisture and dust, you're going to get microbial growth. And basically, I'm sure every one of you has experienced this. Whenever you turn on air conditioning in a car, or first time it's been on, hasn't been on for a while, you always get a kind of moldy smell. And what that's doing is it's showing you what's growing in there. Actually it's a big problem for overflows. Like what happens is if you don't keep the coil clean and the pan clean, you get a lot of bio slime growing, and that's this very thick material, and it clogs the drains, it clogs the lines, and then things overflow. So it causes a lot of problems. I would say, you go into any office building, and wherever there's a fan coil suspended in the ceiling, you'll find some staining underneath where it's overflowed. So air conditioning, if you're in in an environment, or I should say, if you're in a weather zone in the country where there's humidity in the air, then you're going to get moisture on the coil. If you're in the desert, Southwest, maybe that's not so much of an issue. It just goes on and on and on. You can see it's a huge problem. And the thing that the reason this isn't more of an issue, I think, for people is because not everyone is allergic to mold. So if you filter the air properly and you keep the system relatively dust free, then you don't get all that microbial growth. You don't get people with allergy symptoms, and the systems don't clog up. I think, people, consumers are really concerned about improving the air quality, through filtration. And I think today with COVID-19, again, that's not a bad thought. But in the long haul, you want to keep that coil clean, keep the pan clean, avoid any dust buildup. One of the interesting things that I've run into, and this again won't be in every climate zone, but if you're in a climate zone where it's very cold in the wintertime and people have separate systems, so if they have hot water heat and the air conditioning system that's separate, maybe in the attic, as I do, then the vents all have to be closed for the winter, because warm, moist air can migrate up into the attic system and then condense. So I actually had one client who was having all kinds of allergy problems, and he was using a humidifier in his bedroom. You could actually see, this is now on the left here, this is a duct in the attic, and you can see that there's condensation under the ductwork, condensation here. And I actually took the filter in the middle of the winter out of its holder, and there was a puddle of water there. So that's a big problem. This is looking down the trunk line. I actually disconnected one of the ducts from the trunk and looked down, and there was water condensing on all the walls. And inside the duct to the bedroom, it was all black with mold. And you can see here some of the microorganisms that were there. So it's important, if you have a air conditioning system in the attic, for the winter time, it has to be sealed off. Just close all the supplies and put a cover over the filter in the ceiling. Okay, so we said why the fan coil is clogged. There's a good example. Maybe this was an office where there was an overflow and there's mold growing at the ceiling. So the microbial growth on coils and also in fibrous liners is really, it's a leading cause of sick building syndrome, and that would be commercially as well as residentially. So people get allergies, asthma, and there's even a disease called hypersensitivity pneumonitis, which is really a sensitivity to mold in the extreme. It's actually life-threatening. It causes fibrosis in the lungs. So you get fibers deposited between the cells, and then the lung can't really expand and you can't breathe properly. So Jin Yang is a leading microbiologist in the country, and he's been around for many years. And he looked at, he wrote this paper, he looked at 1,200 samples of fibrous lining material, and really half of the samples had mold growth, typically Cladosporium and Penicillium species. And this is just giving you the sort of the whole picture of what it looks like inside of these systems. And again, since maybe 90% of people aren't really affected by it, there's only 10% of people who are really getting that sick. So I had one client in an office. He was working in an office building downtown, and he couldn't go to work because of his hypersensitivity pneumonitis. And his physician wanted me to look at his office and his house, and I took air samples in both. And his house was fine, but his place of work, there was actually an Aspergillus conidiophore and spores coming out of the ceiling diffuser. So it was an 11-story building. All of the units were full of mold growth, and took months for them to clean it all. But eventually he was able to go back to work. His doctor said that he had to work from home. Here was another. So this is a heat pump that was in the basement of an office that I looked at, and the fellow that was renting the thing was desperately ill with all kinds of respiratory problems. He couldn't go in to the office, and the basement had flooded. You can see the water lines on the return plenum, and it was a heat pump, and the filter was filthy. It was disgusting. The internal lining material was was filthy. And a couple of years later, I got a call from another guy, and I didn't recognize the address. And this was an entirely new tenant in the same condominium. And I looked at the heat pump, and no one had ever cleaned it or done anything. And this new tenant, he was so sick he couldn't even go into the office, and it was all from that mold growing in that heat pump. I had a similar situation in a penthouse. This was in a really beautiful building, high-rise downtown condo, and there were what you call vertical stack units there. And these things can supply heating only, or heating and cooling, depending on the coils. The family had been renting the penthouse for it was a nice unit. It was a duplex. They had 3 kids with no health issues prior to moving in, and then they were hospitalized multiple times for respiratory problems. They moved out of the condominium, and all of their symptoms went away. So they assumed there was something there, and so it was one of those vertical stack units. They don't have proper filtration. This is a low MERV filter, and they never get maintained properly. There was mold growth behind the filter, and this is the supply plenum looking down, and it's just every component in there, everything, the lining material, the wires, everything is just covered with mold growth. These things had never been cleaned, and I don't know how old they were, but they weren't even that old. So I took a tape sample from the lining material, and it was just full of cladosporium mold. The air sample in the bedroom had penicillium or Aspergillus mold spores. These are, again, I use pink stains, so those are skin scales stained pink. And this type of unit, vertical stack, really all of the coil, the area is not accessible for cleaning. The only part that you can actually clean is this little narrow band about 2 inches. So 70% of the coil is completely inaccessible. What you have to do to clean these things, you have to cut holes, take the blower out, and seal the lining material. But unfortunately, you can never really get to the rest of the coil. So I did testing after the first remediation, and the concentration of spores, which is either penicillium or Aspergillus, was huge, 15 to 43,000 spores per cubic meter. I mean, you'd want maybe a couple of hundred at most. So they repeated the remediation, and after the second remediation, the management IAQ investigator said that the place had been cleaned. Then the family moved back in, and they were just there for a few hours, and then the kids had severe respiratory problems, so they needed more work. And then I came in, I took samples coming out of the supply grill, and there were chunks of cladosporium coming out there. There was Aspergillus conidiophore and some eulocladium mold, so it was still filthy and full of mold. This was after the supposed cleaning, again, because you can't clean these things. So the older vertical stack units cannot really be remediated adequately. They have to be replaced. Now, they obviously need some better filtration. That would help, but you need to have good maintenance on these things, which doesn't really exist. So this particular manufacturer now is making a unit that has a removable coil, so it can be cleaned, which is great. So the more looks at the filters here, you see often you'll see gaps that, like for most people, the filter is an afterthought. It doesn't get fit properly. It's crushed. Here's another one. It's not doing its job. Water, air is going right around the thing. Here's a big gap. So all filters should be in an airtight enclosure to the exterior. And there is a company that makes a little magnetic thing you can use that'll easily come off, or it can just be taped shut. But mostly they're not doing what they should be doing, and the function is really important. So here was one unit where they left the original filters down in the bottom, and then here it's not being held in place. The air is going around it. A lot of times the condensate leaks down into the bottom of the return plenum. And here's one where the filter is getting wet and moldy. I actually was in a medical facility where people were getting sick, and I was standing at the air conditioning unit in the basement, and I turned the blower off, and a huge flood of water appeared on the floor, and I was completely perplexed. And then I realized what was happening was that the air conditioning coil was leaking water into the return plenum. And because there's a vacuum in the return plenum, it was supporting about a 2-inch column of water in the bottom of the return plenum. So when I turned the blower off, all the water poured out of the bottom. So again, moldy, wet filters, too big, fallen filters. Now, here's an interesting point, which maybe this should register something significant in your mind. Now, a lot of fan coils have the filter directly beneath the air conditioning. And that's really a problem in a lot of cases, because the water, when the blower turns off and there's a lot of water condensed on the coil, it drips down onto the filter. And here's a filter that's the paper's covered with mold. And I've seen this, multiple times. There's the filter, nice media filter, all wet, covered with mold, because it's directly beneath the air conditioning coil. The filter should always be at the entry point of the return plenum in a vertical position, so that if water drips down, it doesn't get wet. More filters with mold growing on them. So this is the type of filter you want to use, and in the position where it should be. The April air filters are very difficult to assemble, so I like the filters that come pre-assembled in a cardboard box. So they're a lot easier to install. So I have a whole bunch of these pleated media filters. I'm very fanatic about keeping things clean. Never find dust on the coil, not on the filter. When they put in my second floor air conditioning, I insisted on having an access panel to the return plenum. And I opened the thing up one day, and there was a puddle of water on the bottom of the return plenum because water was dripping off of the coil. So I installed a plastic tray, and every once in a while I go in there and clean that out. The unit was still bothering me, and I took the blower out, and there's it's hard to see, there's a little label inside the blower, and there was mold growing on the paper. So I would say that if you have high humidity and moisture, it's next to impossible to prevent this from happening. But the best you can do is to use good filtration, at least MERV 8, or preferably 11 or 13, and then keep good maintenance. Now, electronic filters are touted as the end and be all, and but they cease to function when dusty, and the manufacturers are recommending that they be cleaned a few times a year, but in reality they really have to be cleaned monthly or more. And I've actually seen hundreds of electronic filters, and not a single one of them was working. And the reason is this, that you get the process of trapping particles depends on having a very high electric field. When you get dust on the wires, that really basically destroys the electric field, and so there's really no cleaning taking place. So here's mold growing on the filter, electronic filter, more blower cabinets full of filth, acorns from probably mice. There you see a little mouse asleep on the job. This is a shrew asleep on the job. So, a lot of times when they make a transition to a pan bay from the unit itself, they'll leave a gap. I've seen that a few times, so the mice can get into the return system from the top of the furnace or air conditioning. if you don't clean the filter, replace the filter regularly, it gets dirty, it gets sucked in. This was an installation where they actually had a media filter, but there was no bottom on the blower cabinet. It was in a filthy basement. And here are some blowers. Now that, if you don't clean the dust, the blower impacts on the dust impacts on the blower. If it's after the coil, a cooling coil, there's going to be a lot of moisture in the air, and there may even be water droplets in the air, mold. So these have to be taken out and cleaned. You can't just, blow compressed air on these things, because that just blows the mold into the shroud around the coil, around the blow. More, I'd say most of the blowers, the labels get moldy. I think either the paper is moldy or the dust is moldy, but the blowers, the labels should all be laminated with some kind of plastic or tape. More mold. So now we're moving on to humidifiers. So this is an old style humidifier. You don't see this kind of a tray anymore. This came from a rotating drum humidifier. In that style of humidifier, the drum rotates in the water, and the water in this case, and in most cases, would get full of dust, biodegradable material, and then you get microorganisms growing in the dust. And then this drum here rotates around in that puddle, and then air goes through the sponge and aerosolizes the material. So these things have made a lot of people sick. This white material here growing on top of the water is actually, it's a type of bacteria called actinomycetes, and they cause some pretty serious respiratory problems. So these humidifiers, I don't even know if they sell them anymore, but they should not be out there anymore, and they should not be on the market. You do not want to have a sort of reservoir of water if possible. So, window air conditioners, you've got the same issues. You have to have a decent filter on there. Without a good filter, the dust builds up on the coil, the dust builds up on the blower, and you end up with the same situation. So what we recommend for window air conditioners is that every season they be taken out, taken apart, and thoroughly cleaned with a hose and bleach. So these things can get very, very moldy. Now, this is actually, I believe, this is a picture. No, it's not mine. Mine was worse. When I purchased an air conditioner at the end of the season once, and it was much too big for the space, so it didn't really dehumidify adequately. I developed asthma. Whenever my air conditioner turned on, I would start to cough. I tested the air. I didn't really see much in the air, but when I opened the air conditioning unit up, the blower blades were all black. The entire lining material was black. The coil had mold on it. And, at that time, I wasn't really that knowledgeable about all of these issues. So that's how I got asthma. So in humid climates, the water condenses on the coil, and then that you get air close to the dew point, and then it goes over the blower, and any kind of dust on the blower or labels can get very, very moldy. So these are some labels. Here's a label on the left from a ladder. It says, failure to read and follow all instructions for this ladder can result in death or injury. So, and it's in Spanish, electrocution hazard. So there have been a lot of lawsuits, and so that's why sometimes there's more labels on the ladder than this area for any metal. And the same thing, for like cigarettes and liquor, even coffee cups come with a warning. Now, I remember that woman from McDonald's got burned from a coffee cup, and she sued them successfully. So I think it's time for air handlers to come with a warning label, and it should say something like incoming air must be filtered to avoid microbial contamination. And the ASHRAE recommends you use a filter with a rating of at least MERV 8, and then failure to maintain the filtration can lead to illness. So this is a serious warning. I mean, I guess since not everybody is affected by it, it doesn't get out there. If 90% of people got sick from mold instead of 10%, then we'd probably see these warnings. Tight buildings have to have fresh air. Most people believe that. And so some of the building codes, I think now, I know in Canada they do, they're actually requiring the use of air-to-air heat exchangers because the buildings are so tight. So this is, and I know some of you sell these things. This is a kind of a schematic of a air-to-air heat exchanger. There's the core. So fresh air from the outside comes in and goes to the inside. And then you take stale air from the inside through the core and you exhaust that air to the outside. We're not showing the blowers here. And then you've got, if you're in a cold area, you need to have a sort of defrost cycle because you're bringing in all this freezing cold air and you're passing it by warm, moist indoor air. So the filters typically on all of these, they're only the area of the exchange core, and they're usually inadequate and they do not often fit properly. So as is true of most mechanical equipment in buildings, they do not get maintained properly. I talked to this was from a school actually, the building, the superintendent's maintenance guy for the building. There was this big silver box. He didn't even know what it was for. He never opened it in 4 years since it was installed. And one of the teachers was sick, and the whole inside of this thing was full of mold. Here's another older unit with a paper frame filter with mold growing on it. This was another one. This was an air-to-air heat exchanger that I turned it off to open it up. This family, they all had allergies. This HRV had been running for 9 years and they never maintained it. And it was full of mold. The unit wouldn't turn on again. I guess, it had been running for so long, something was wrong with something, electronic component. So that was on a Friday, and I talked to the people on Monday, and all of their allergies had gone away. They stopped running their air-to-air heat exchanger. So these things can be a big problem. They're put in to solve a problem, but it's one more item that's going to need a lot of maintenance, because whenever you have airflow, you're going to trap dust from the air, whether it's from the outdoors or from the indoors. So that air has to be filtered no matter what. This was an older unit. They had this air heat exchanger had a light bulb for the defrost cycle, and it was actually mold growing on the light bulb. So this would be on the outdoor air intake side. And then this is again outdoor air intake side, leaves lack. You can say, oh well, they should have been maintaining it, but I mean, I don't think people realize the consequences of it. So it's not enough to say, maintain it. And that was the one that's been going, I think, for 9 years. It was just a pile of dead bugs in there. So the filters they're small, they don't fit properly. So, what I've been recommending to people is that, just to use supplemental filtration. So here's the outdoor air coming in. And so I recommend a pleated media filter here, and the ductwork should be insulated too, because you're bringing in very cold air in the winter. You can get condensation issues, and then you're bringing in dirty indoor air. So the indoor air should also have its own filter, and it's an inline filter. It has, I believe, 5-inch openings to attach to the ductwork, and then the filter's at an angle. Now the FB6 comes with MERV 12 filters, which would overwhelm the blowers. So most of these HRVs, so I think you've got to use a MERV 8 filter rather than the 12 that comes. And then I wouldn't recommend putting the ERV in the garage. This was because all these systems are leaky, so you're going to get get combustion products in there. The blower was completely filthy already, just from in this new house. It was just from soot from cars. But this was an interesting situation that I looked at where this woman was chemically sensitive, and she was buying a condominium, and she wanted me to look at it beforehand. So I requested in advance that they turn all the mechanical equipment off so that I can see just what the air was like without anything. And in this particular new construction, the kitchen cabinets were off-gassing pretty badly. And it was a pretty overpowering chemical smell in the kitchen. So then we turned on the HRV, and within 5 minutes, it was like being outdoors. It was fresh air. So these units can really make a huge difference in the air quality, but only if they're maintained. That means cleaned regularly and having supplemental filtration, in my opinion. So these are the the kitchen cabinets that were off-gassing in that unit. What I recommend for these is that you have in the less expensive cabinets, the shelves are made out of particle board, which can off-gas a lot of formaldehyde. And so I recommend that people seal the edges of the shelf with aluminum foil tape. And I even recommend that the unused holes be sealed with something, because if you look at in a lot of these cabinets, there'll be 20 or 30 holes, and those are all providing surfaces for formaldehyde to off-gas. So now we come to even a little more modern kind of equipment. So these mini splits, and so the mini splits are extremely popular. Of course, the only problem is that the government mandated seasonal energy efficiency ratio for these things is, I don't know what it is now. It was 16 the last I heard. And so the manufacturers, in order to meet that the seasonal efficiency ratio, they reduced the power of the blower to the point where you really cannot have a filter on a mini split. And so the filters that they use are just a little insect screen like the ones on the window air conditioners. So they're totally inadequate. And so the dust builds up on the blowers, and it builds up on the supply louvers, and then the air again coming off the coil is damp. There may be water droplets entrained in the flow, and so they get moldy. And I would say probably 90% of the mini splits that I've looked at had mold problems on the blower. Like if you look inside the louvers, you open them up and you'll see that the blades are impacted by a lot of dust, and you see black spots on the dust. You know that there's mold growing there. And again, that may not affect most people, but some people can get quite sick from that. So there's got to be really a balance between saving energy and having clean air. So I think in a lot of situations they are antagonistic, because you're trying to save energy. That means you can't have good filtration. So these are pan bay returns. They can get very dusty. They can't be cleaned properly. I've actually had one situation during construction. The basement was wet. There was mold growing on all the framing, and then they made the pan bays with the moldy floor joists and sheathing in there. So the homeowner was getting sick from that. This was something that always perplexed me. If you look at a horizontal duct, usually it's in a basement going across the basement ceiling. If you look in the supply register, you'll often see a layer of dust very sort of evenly at the exact lower half of the duct. And that always perplexed me until I finally realized what was going on. So if you have a furnace and the heat is running, when the heat shuts down, there's a lot of residual hot air inside the furnace and the duct system. So that hot air, by convection, rises out of the duct, but air has to replace that. And so cooler air from the environment sinks into the duct and goes back to the furnace. And so the lower half of the duct is coated with house dust and the upper half is clean. So return ducts bear the brunt of the dust and dirt that's coming in. This was actually mold growing on dust in a duct. The woman was deathly ill in this house. This is, kind of typical if you don't clean the ducts. And, the EPA has a little booklet called Should You Clean Your Ducts? And they based that booklet on, they looked at maybe 40 jobs, 40 different companies, and most of the companies were what they call blow and go types. They just have a big vacuum truck and they just suck the air and the dust out of the ductwork, and they don't clean the coil, most of them. So they didn't get very impressive results. And really what they were looking for is an increased efficiency in the system. And so they said, look, don't clean your ducts because it's not going to make you save any energy. But in reality, the ducts have to be cleaned because of all these other issues. So you can have allergens from prior home, owners, you can have mold, all kinds of things. So duct cleaning, if it's done right, is important. Just tons of debris. I mean, I remember one place, the tile people shoved the extra grout into the drain for the toilet. So, I guess this is probably a return duct too. Okay, so duct board, this is moldy duct board. Now, that's a product I don't think it's used anymore, but whenever I see it, I always tell people to get rid of it because it traps dust, and then when the conditions are right, you can get mold, or you can have dog dander, cat dander, whatever, cat throw up. So here you can see where the air conditioning has been leaking onto this duct board. It's all full of mold. Got to be replaced. Sad story. I actually got a dust mite out of the duct one time, and it was completely covered with soot. It had been in a puffback in the house. It was an oil-fired furnace. So just a brief note away from hot air heating systems, baseboard convectors can get very dusty because they heat air by convection. So the air at the bottom gets heated up, it rises, and then brings in cold air at the bottom. And so all the dust accumulates. And what you often find if people have pets, you'll see there's a mat of pet hair, and then the pet hair is acting as a filter, and it traps all that dust. And I would say every baseboard convector that I've looked at where I took a dust sample in a basement had mold growing in it, because you have to think about the water temperature in the boiler in the summertime. It can be cool, especially if it's been cool for a couple of days, and then it gets very hot and humid. So the fin tubing can actually be below the dew point, and so you can actually get mold growing in the duct. The fin tubing has to be cleaned, and I recommend you. And in fact, I just did that. I just did that this morning with my own baseboard convector. I blasted it with steam. You vacuum it, HEPA vacuum first, and then blast it with steam from the steam vapor machine. Now, some companies are actually using steam vapor machines to clean air conditioning coils, but the coils are very fragile, so you have to be very careful not to bend the fins with the steam, but it's a good way to clean them. And the same thing goes for radiators. The radiators are often full of dust, and the dust can get moldy, or it'll be dog and cat dander and all kinds of things that have ever lived in the house. Dust mite poop. Okay, so we're moving on to dehumidifiers. Same issue. You have a cooling coil. Anytime you have a cooling coil, you have to have good filtration. So a lot of people dehumidify their basement. They saw wood down there. The basements are filthy, dirty, dusty. The dust accumulates on the coil, and it all gets moldy because it's wet. This was an interesting one where you can't see this in the picture, but it was actually like schnut. There was this horrible gelatinous bio-slime coming down it was like gelled water. So whatever was growing in there was causing this gelatinous growth, and of course it would clog the drain at some point. And, you know, a lot of people run these things in the winter. They really shouldn't. You want to keep the relative humidity in the basement at no more than 50%. Few of these machines really have that, you know, capacity. And if you run them in the winter, they get cold and covered with ice. I have pictures of a bunch of them just completely in a block of ice. Then I'll mention it. That's a thermistor, dehumidifier. They're the only products that I recommend. They have stainless steel drip pans. They have, you can put a 2-inch MERV, you know, 11 filter up there. They can be ducted. So these are outstanding products. So looking again at my system, so I'm, you know, I have all these allergies, and I was very, very worried about installing air conditioning in my house, in this new house. In fact, I thought I might not even install it. I realized I couldn't sell the house without central air. We decided to put in an air conditioning system. We have two units, one for the second floor in the attic and one in the basement for the first floor. Now, at the time, I was in contact with a fellow who was trying to patent this system of grills with filters in them. So he actually gave them to me to test. So I actually have a coarse filter on every return. So what you're looking at, this is the, you know, the where the grill marks are, and this is the dust that collects on that filter. We have 11 returns, 11 filtered returns. In sort of contrast to all of these other pictures that you were looking at, you can see that there's no dust at all inside the ductwork. I have the cleanest ducts that I've ever seen, and that's because we have these, you know, pre-filters. The filter kind of folded up on one of them, disconnected, and there was some dust inside the duct, and it was on the second floor outside my office where I have a laser printer. Now the skin scales are pink, and that's a mold spore, and these are the primary ink colors of the laser printer. So without that filter, the laser pigment particles got into the return system. So there are some more kind of green alternatives you might be seeing, and one of them at one of the universities here in this new building installed an underfloor supply plenum. So this is like the opposite of a, you know, ceiling return plenum. And the other thing I'm going to talk about a little bit is conditioned crawl spaces. So this is looking underneath the floor. The floor consists of very heavy carpeted metal panels that you can lift up anywhere in order to access the plenum. And then there's the poured concrete floor at the bottom. And this space is supplied with either cooled air or hot air. And then there are floor registers in some of these floor panels that allow the air to get into the habitable spaces. They have electrically operated louvers so that you can control the supply. I mean, this is like such an insane, complicated thing. Now, this insulated line here carries fluid, I guess, for the fan coils. You know, it's ethylene glycol and water. And one of the air quality issues in this place was that the ethylene glycol was leaking into the concrete, and you had the hot air for the supply kind of going over that. So here's a BX cable move, and you can see the corrosion there. So there's, you know, there's some things going on here. But another big problem that they had was, you know, the posts that were holding the floor up, they had used a glue, a polystyrene based adhesive, and it was off-gassing terribly. I mean, there was a horrible chemical odor, and it was what they call 4-phenylcyclohexene. And that, and those of you who remember the EPA at one time, this is like what, in the 80s, I think, they had to eliminate hundreds of thousands of square feet of carpet from the EPA building because people were getting sick from the new carpet, and it was due to this phenylcyclohexene. So phenylcyclohexene is an impurity in the adhesive that they use to bond the web to the fibers. Okay, so that was the underfloor supply. So here's typical look at a crawl space, dirt floor, full of mold, and it's the last place on earth where you would want to really have your air coming from. So unfortunately, the building code now allows you to include a crawl space into the duct system. It can either be part of the return or part of the supply. And it's, in my opinion, a very unfortunate change in the building codes, because I don't think I've ever seen a crawl space that was clean enough to be a duct. So if you're ever involved in a project like that and you see that somebody wants to do this crawl space, I should say the idea for this was that you have a conditioned crawl space so you don't have to ventilate it to the exterior. But really the crawl space should be totally isolated from the house and dehumidified. Okay, so the HVAC industry really needs to be, educated about the significance of, filtration and the health consequences of inadequate filtration. So I always say, if you want to sell something to improve the air quality, the most important thing is to actually sell people on using good filtration, MERV 13 or MERV 11. So that's that.
We appreciate that, Jeff. Yeah, a lot of our reps here, I was telling you this in previous conversations, and just for the collectively for the group, what I told Jeff was, in our upbringing, if you will, in indoor air quality terms, we're always preaching fit the solution to the house and the homeowner, because every one of them is different and there's multiple ways to treat the space, and there is no one silver bullet, if you will. But if you look at all the different solutions, and I know from your standpoint too, there's a lot. Source control can actually do quite a bit, but if first and foremost with like water leaks and everything else you just mentioned that you see for all your field experience, obviously, but there's multiple solutions for all the various types of things you run, and just your experience is invaluable as showing us what can happen when things go wrong.
Yeah.
I think a lot of us have experienced them firsthand. I know I have, and I wished I had been wearing a mask all those years I was changing all those air filters out. So.
Right.
All right, well, Jeff, I want to thank on behalf of all of us, thank you for sharing your time and sharing your field experience and all those cases that you've your experience is greatly appreciated. Appreciate you sharing it. And
well, thank you, Rob, for giving me the opportunity.
And best wishes to you going forward, and maybe a new book someday.
Well, I don't know.
You're gonna have more stories to tell. I know you are.
We've talked about it. But the thing is, my house is killing me. The first one, people love the stories. It wasn't too scientific. And then, the mold survival guide was a little more scientific. And then my office is killing me was, even, more science. And so people, they don't like science. So then we decide, all right, we'll go totally practical. So the last one, the healthy home tips, is the least science of anything. Yep. And now this one with the next second revision, and my house is killing me. It's a big improvement. There are new chapters. There's a lot of new information. It's all the pictures are in color, and so it's
excellent. I've got my copy and I enjoyed it. It's a nice read, very nice read. It's really good stories. All right, Jeff, we'll let you go. We appreciate your time.
All right. Okay, thanks. Goodbye, everybody, and stay healthy.
Thanks.